Hi, I'm Christoph from Berlin, Germany, and I work for KDAB. In this series, I talk about my daily life as an embedded developer. And in this video, I will show you how to install my favorite tool for debugging Qt applications, GammaRay, on an embedded target. So, most of this video will guide you through the steps of getting this program analyzer onto your specific embedded board. So without further ado, let's get into the first part, how to set up GammaRay. Maybe as a warning, this process is fairly complex, but I will guide you through this. So first, let's get an overview of the technical setup. On the left, you have our GammaRay UI on our desktop computer. This we will use to actually see the results of our analysis. On the right is our embedded target that we will want to analyze. To extract the information from our app running there, the so-called GammaRay probe needs to be installed on the target. Once the setup is complete, the UI and the probe can talk via network and exchange information both ways. From the target, we can get all kinds of information, signals, events, GUI details to inspect. From the desktop, we will be able to even remote control, inject events and signals, and trigger changes. Let's start by cross-compiling the probe for our target, which is the hardest part. I made this little overview graphic for all the steps we need to check. First, check out the source code in the right version. Be aware that the probe and GammaRay UI talk via a common protocol that might change from GammaRay version to GammaRay version. If GammaRay version and probe version do not match, they cannot transfer all information correctly and you're in trouble. Thing is, you would only see that at the end of the installation, so be aware and check it right away to save time. If you don't have GammaRay installed by now, things are super easy. Just compile UI and probe from the same source code folder and it will work. If you already have GammaRay, check out the sources for your probe according to your GammaRay version on desktop. You can get your GammaRay Git revision when running GammaRay ---- version, which will also show the protocol version. Next, we just make a build folder called build GammaRay SDK next to our GammaRay folder. In this, we will cross-compile GammaRay. To allow the probe to work, we will need the exact same Qt version as the app that you want to inspect on your target. Luckily, this is the case for almost all embedded software, because embedded uses the same SDK for all apps on the target anyways. Just make sure to use the same SDK and you should be fine. GammaRay uses CMake for its compilation. So to compile the probe now for your target, you will need a working CMake CrossCompile environment. If you use a buildroot SDK, use -d cmake toolchainfile equals host share buildroot toolchainfile.cmake, and this will tell CMake how to cross-compile for buildroot. If you use Yocto SDK, firstly source the environment setup Linux file, and then secondly use GammaRay's own toolchain file for Yocto, which reads all the important locations of compilers and so on out of the environment variables set by that first step environment file. So the CMake toolchain file equals GammaRay, and inside the CMake folder you will find toolchain-Yocto. Use this for the Yocto version. Now I pick the right parameters to only compile the probe because I only need it for the target. So -d GammaRay probe only build is true, means we only want to build the probe. GammaRay build UI is false, means we don't want the UI for the target. We set the install prefix to the current directory, and we use the CMake type build type as release because we want GammaRay to be built in release and run fast as possible on your target. In the last necessary step, I show you how to deploy the probe, so to install it on the target. After successful cross-compilation, we need to deploy the probe on the target. The probe consists out of multiple library files that we move on the right location in the target. If you followed the instructions right, you should now see a lib folder inside your build folder. Copy all the contents recursively into user lib on your target. So scp-r lib GammaRay, everything there, to your target user lib. And now I can start my application and inject the probe. On embedded, the best option to attach the probe is to use ld preload. Instead of starting your application normally, just prepend ld preload equals and then the long path to GammaRay probe.so, which you can see here. And after that, your normal application. With this, your application will start with the injected probe and will send information to GammaRay. We are now finally here. We successfully added the probe to our application. So now that we are ready, we can test our setup. On desktop, we will start our GammaRay UI and look for the Connect tab. In the optimal case, you should see your target IP announcing itself as an available GammaRay probe. If this is not the case, you can try to connect directly via the URL field above. Do not worry too much about performance here. To my experience, GammaRay does not slow down your app too much. And if you don't have a GammaRay UI attached on your desktop, the cost is almost zero. So during development, I usually leave the GammaRay probe attached at all times and start my application always with a GammaRay probe anyways. This first part was just for getting GammaRay running on embedded. If you want to learn more about GammaRay, I highly recommend our full GammaRay series, where you can find the link in the description. It will show way more details focused on desktop, Qt and QML debugging. If all these steps here were a bit too much, but you have access to your Yocto and buildroot recipes, I can recommend my blog post on the GammaRay recipes for Yocto and buildroot. I put the link in the description as well. In the next video, I will show you some typical problems that you can solve. And now that you have GammaRay in your toolbox, see you and auf Wiedersehen until the next video.